So welcome everyone. I'm Asif Bakar from Zorbix Technologies. We're the only certified Databricks partners in state of Wisconsin. So I'm an alum of MSOE as well. Uh, we started to talk with Dr. Riley because we've been sponsoring Databricks user group meetings all year since last year, right? And this was a great opportunity to sort of partner with MSOE to get the students in this place, to get industry start to come in and learn more about Databricks, and to get all of you guys networking a little bit, right? Because Databricks as a platform, while available at MSOE, is not necessarily available where you could just go nuts at it, right? You have limited compute available, it costs a little bit. So if you do a project in Databricks, it'd be new to you, but here's an opportunity to kind of learn about this tool, learn about this platform, learn about all that's happening here because the number of innovations that are coming out on this platform are insane. Every year we get out to the partners meeting, we get 60, 90, 100, 200 innovations popping up on this platform all the time, right? So if you start to compete, if you start to look at the marketplace on the cloud big data platform, data lake platform, we have Databricks. There's another platform called Snowflake. Those are the two competing. Of course, Microsoft got Fabric coming out, right? So learning about this platform is important. And that's what we're trying to do is build a community, get students come in, get industry come in, you guys network, learn, and we build this community. Make sense? With that said, this is our first meeting here at MSOE. So thank you, Dr. Riley, for partnering with us and allowing us this space and beautiful technology we have for the virtual folks to join us as well. And we're going to start popping out some great, topics for you guys to learn from. And I'm going to transition to, we have Ryan Shiva, who is one of the MVPs, certified Databricks, very few MVPs in the world. So this will be a great chance to learn from Ryan about AI agents today, right? Ryan, all you. Thank you, everyone.
Yeah, thank you, Asif. Thanks everybody for joining us. So this is the Wisconsin Databricks user group, and my name's Ryan Shiva. I'll just share a little bit about myself. Asif already kind of mentioned, but I'm a Databricks engineer. I work at Databricks Technologies, and I work with Databricks full-time. I'm also a professionally certified Databricks engineer for data engineering and also machine learning. And I was recognized by Databricks as a Databricks MVP because I write blogs, give these talks, and I'm like sharing my knowledge of Databricks with the world. And today I'm going to talk to you about AI agents in Databricks. I'm going to kind of give you a rundown of what AI agents are, and then so you'll kind of learn from a platform agnostic standpoint, like why you'd want to work with agents and what's the benefit. But I'll also be talking about like the Databricks tooling and the platform surrounding how to build AI agents in Databricks. And then after I give you kind of like an informational presentation, then I'm going to give you a live demo in Databricks. Now, before we get started, I just want to mention Databricks community. So this is an online forum. It's run by Databricks, and you can ask questions from the community. It's a great place to find out more about Databricks products, and they've got information about like the different learning paths that are offered by Databricks for the certifications and other training. You could also join regional groups on Databricks community. So for instance, there is a user group community for Wisconsin. So I would encourage you all to join that. So the way to join is you go to community.databricks.com, and there's also a QR code here if you are interested. But you can use your Databricks account and you'll be able to get into Databricks community, but otherwise you could register here. It's really fast. You just need your email and they'll send you an OTP code. So it's very simple and convenient. And I also want to mention there's a Wisconsin user group group within their community website. So there's a QR code for that. And then Zorbix also has our own website for this Wisconsin user group. So I would encourage you to join both of these, so that way you can get notified about when we're having future groups. Okay. So next, I just want to go over the agenda for the presentation I'll be giving. So first, I'll just introduce you to the basic concepts. There's AI agents and then AI agent systems. You're going to learn what those are. And then I'm going to show some real-world use cases for those systems. After that, I'm going to go over a process for how you could actually build and scale an AI agent system. And I'll kind of like weave in there how you would go about doing this on Databricks with a different tooling. And then I'm going to conclude basically just with some general guidelines for working with AI agents and best practices for you to follow either on Databricks or really any other platform. So by the end, you're just going to understand a lot more about AI agents, AI agent systems, all of their different applications, and how you're actually able to build them effectively. So while I'm presenting, if you guys have any questions, or I'm kind of assuming a little bit of background knowledge for Databricks, but if I'm talking about a technology or term you don't understand, just feel free to interrupt me, and I can take any questions. Otherwise, you could save it for the end, and I'll have a Q&A after the presentation too. And that goes for anybody that's joining us virtually. So just put your questions in the chat, and I will answer those. Okay. And then after the presentation, I'm going to show you how to build and evaluate AI agent systems in Databricks, and that's going to be the live demo portion. So you'll see Databricks Mosaic AI, and that just makes it really easy to deploy these systems in a way that's like really high performance, and you want it to be properly governed and really like meeting your organization's goals. So let's dive right in. First question is, what's an AI agent? So they're intelligent applications, and they are designed to automate different tasks, and the goal is to enhance productivity. They're able to analyze information, and they can even make decisions and take actions to achieve specific goals. And that really has the benefit of freeing up time and resources from humans for other work that really can't be automated as easily. And the key thing to understand about that is at the center of an AI agent, you've got a large language model, an LLM, and that is sort of like the brain that is doing the reasoning. That's the piece that processes your inputs and is actually making the decisions. So in order to illustrate that, I just want to go through a few examples of how they could actually be put to practical use. So first, you've got customer service agent. So for that, you could imagine like you've got a chatbot on a retail site, and that could help you find product information. I'm sure all of you have interacted with that before. And so it could interact with your customers and understand what different questions they're asking, and it will provide a response that's just right away, so they don't have to wait. And then also the answer is going to be very relevant to what they're looking for. That's the goal. So that the idea here is we're improving customer satisfaction, and you want to like resolve issues very efficiently, so you're not wasting a lot of like human agents' time. After that, so next we've got the campaign generation agent. So what that is good for is like if you're a social media manager and you're planning a marketing campaign, this is really good to help you increase brand awareness and drive sales for a company. So you can connect them to different market data, and then you can use it to generate a whole marketing campaign. And the great thing about using agents is you can really like personalize it to your specific brand, and you kind of get it to know your target audience, so it's able to market more effectively. And then I'll mention code generation agents. So that's the last example. They generate code, they can help you write code, but also debug and optimize your code. If you're in the field of software development, you probably are very familiar with like using ChatGPT to help make your work more efficient. But agents are a really great use case for this because you can feed it the proper like project context and surrounding code requirements, and they can really help speed up your development process. And that helps boost your productivity by quite a lot.
Having professors and students here, this might not be the right topic, but.
Yeah, save it for when you're out of school, but.
No, I think it's all, I mean, I have no problem with students using LLMs. I was actually talking to somebody, sort of derail your conversation, but I have to talk about this. So I was talking to another faculty today, like, there are lots of textbooks that have answers in the back, and yet we still work through the problems in the book, right? And it's the same thing with learning, right? An LLM gives you the answer to just about everything in the coding, class. Doesn't mean you should just use the answers, right? You have to learn the process. So I don't have a problem with students using LLMs as long as they aren't just using it to get the answers.
No, I totally agree. And not like blindly trusting the answer, but like verifying, right, with a trusted source. But I will say, like, in the industry, if you're not using LLMs to make your work process more efficient, you're going to be left behind the people that are. So better to learn it sooner than later, but don't just obviously use it as a crutch.
Ryan, can I just make a comment? Just the positioning of the desk is such that you are in the middle of the big screen. Is there a way we can move this so people can read it? I don't know if, or
You want me this way?
just a little bit this way to the left.
Sure.
Can you guys see the screen behind Ryan? And Ryan's a tall guy, so.
Is that better?
Does that work? Yeah. Does that work for you then?
Yeah.
Okay. Because I was just like,
It's over there too.
yeah, for folks here, other folks can see it there, but folks here, this is perfect.
Awesome. Yeah, thank you. So here I've got a diagram, and the idea is I want to display like what's actually the role of an AI agent. So like I said, it's going to use an LLM as kind of the reasoning piece, and it's really helpful to think of this as the brain of the system. So the example here is a customer that wants help returning an order. And I just want to talk a little bit about how if you're using a traditional LLM, not an agent system, it's going to have difficulty with a specific query like this. Because if you just use a traditional pre-trained LLM, it's just going to look at the input. It's going to generate a response that's sort of like the predicted best output based on the training data set. But if you're just using a foundation model like ChatGPT, that training set, which is like the internet, Wikipedia, that's not going to have the information about an order for a specific company. It doesn't have that enterprise data context that you need to answer the question. So the response you get would basically be totally generic and not helpful at all. So that's where the AI agent comes in. So what it could do is it parses the query, and then it will reason about what to do. And it can actually break this down into multiple steps where you've got some different intermediate outputs here, and it will reflect upon that and then make decisions based on the outputs of these different steps. So you could see it's thinking about what to do to solve the problem. It's actually pulling some information from an external system, so it could hit that with, say, an API, or in Databricks, it can read a delta table from your catalog. And then, so in this particular example, we're looking up like what's the user's last order, and it will query the data and find the solution. And then once it has the context to actually understand your question, then it can, next step, perform actions. So it will be able to either hit an API to start the return process, or set a shipping label, for instance. So it's able to reason in steps and then act. So that's kind of the power of AI agents. Next, let's go over AI agent systems. So to actually build and deploy an effective AI agent, you are going to want to use an AI agent system. And this could really involve either a single agent or multiple interacting agents. So what this is it lets you build and operationalize an agent or a set of agents, and that helps them perform more complex tasks just by combining these different components together. So the components could be, say, LLMs, classical machine learning models, it could be enterprise data, and then tools. So The other thing about AI agent systems is they typically have like a built-in evaluation technique and also governance, which we'll talk more about later. So that pretty much just ensures that the system is going to have the most quality and reliable output, and you make sure that it's actually achieving the goal that you want it to. So now I'm just going to outline, here's the general steps you would follow when you're developing an AI agent system. And this, like I said, kind of goes for whatever platform you're on, but this works really well with Databricks, and you'll see how they have different tooling to address these different steps. So first, what you would do is prepare your data. So before you're even building the agent or anything, you need to organize and pre-process your data because your AI agent system is going to need relevant data that it can easily access in order to make those decisions, to feed into the decision-making process. And then once you have your data, then you can actually build the agent. And like I said, that could be Gen AI models, classical ML models, also tools like hitting an API or a, I don't know, vector search index. After that, you wanted to deploy your agent, and that's just putting your agent into a real-world setting, and it will have interactions with actual users. After that, while your agent is in production, you need to be constantly monitoring it and evaluating it. And that's just to make sure that what it's outputting is actually meeting your objectives. And you could actually improve these systems over time by getting user feedback and testing. And then while these other steps are going on, throughout the entire process, development, you want to be governing effectively. And that applies to all the different aspects of your AI agent system, your data, your tools, your models. And that's so that you've got security, compliance, you're aligning with ethical standards, and then you want to have careful like tracking and auditing. And that's just to ensure accountability for your system. So I'll briefly talk about an AI agent system example. So you could build a RAG application. RAG is retrieval augmented generation, and RAG apps are really good for unstructured data tasks. Like in the example from earlier, say you had a lot of PDFs that contain policies on your return process for a company, not like well organized and tabular, but just unstructured PDFs. RAG is really good at pulling out the exact context, the relevant context that you need to answer a question from that unstructured data. So that the idea is you're combining the LLM and then some kind of data retrieval system, like I said, a vector search index, and using those multiple tools that you kind of add together in a modular fashion, that makes it a really effective decision maker, and it will also be able to take action. So now I want to get into some real world use cases for these AI agent systems. And what I really want to highlight is these can be useful across so many different sectors and industries and business functions. So you can, these are really helpful in financial services, healthcare and life sciences, communications, media and entertainment. In finance, for instance, a really common problem would be fraud detection and prevention. So like say you have a credit card company and they want to monitor transactions in real time, and that's to detect and prevent fraud. What the AI agent system can do is analyze patterns, and then it will identify certain anomalies in the transactions, deviations from a user's normal spending pattern, and then it could flag suspicious transactions so that you could investigate further. And the benefit of this is it's happening in real time. You can be more proactive about managing risk for your company. Next, I want to talk about customer support automation, which we already kind of discussed in the previous slides, but it's so beneficial that instead of having a live customer service rep having to answer all these different customer questions, especially things that are like repetitive or the information's on the website, then you could just have a chatbot right on the website, and it provides really fast and accurate responses. So that works better for more routine, simple inquiries, but the benefit is that it's freeing up your human agents to focus on the more complex issues and stuff that can't be automated, basically. So the way you would set this up is you could have more like a multi-tiered support system, and you'd have an AI agent system that's kind of like at the lowest tier that's handling the most common questions. And then for questions that can't be answered by the chatbot, then you've got humans at like a higher tier you can escalate the issue essentially. And this is kind of a related example, but you could have a personalized recommendation engine as another example of an AI agent system. And that is really good for analyzing user behavior and preferences. So this would be commonly used in entertainment. Like I think of YouTube. YouTube has got an algorithm, and you could actually use an AI agent system that's analyzing users' past viewing history, and then it could recommend new videos to you, which is basically based on those patterns and that data. And that's beneficial to both the user because the user gets recommended new content that they're interested in, and also the service, the platform is getting more engagement off of their platform. Okay, I'm gonna move on here. There's a few more examples. So like retail and consumer goods, manufacturing, and public sector could all strongly benefit from AI agent systems. Kind of for a manufacturing use case, you could have automating certain operational tasks. So that could be either there's like scheduling or things related to inventory management, processing orders. These are great use cases for these kind of systems. So for instance, you could set up a system that's got access to your inventory, and then it's got this real-time monitoring where if you're getting low on stock, it's able to monitor that and flag that, and it could even take an action like place an order for you when you're getting low. It could update your inventory for you and so on. So that really kind of like takes the human out of the equation to do something kind of repetitive and reduces human error, basically. And that's just increasing your efficiency. And then just kind of one more example I want to highlight here. AI agent systems can be really good at automating data collection. So that could be good for like analysis, reporting, and this would pretty much apply to any industry where you're processing a large amount of data. It's a huge volume of data, and you need it to be like very fast and very accurate. And so what AI agents are really good at doing is like pulling data from multiple systems and aggregating, and then it could say like generate reports or dashboards. So yeah, just anything where you need some kind of like quick insights from a large volume of data. It's really good. Okay, so now you've kind of seen what is an AI agent system. You've seen like how can it be useful. So next, I just want to talk about how could you actually build one of these for yourself. So first, this diagram just kind of shows you a high-level structured approach that you could take to actually building one of these systems. And I just want to highlight, like, it's not enough for you to just build the system. You need to have a whole framework for like ensuring it is reliable and performing the way you need and meeting your goals. So that's why you've got these different stages here. That's to ensure like the reliability, right? So I kind of went over these steps before, but you've got prepare your data. That could involve data ingestion. You're building the agents, incorporating those different components. Then you want to deploy it. You're going to have some kind of MLOps or LLMOps framework, and you're going to have some kind of model serving. And then when you're ready to evaluate, you could use LLM as a judge or tracing. That's like looking into the outputs that the model is producing. And you can see like at each step how they were making the decisions, what kind of tool or API they were hitting, what kind of data they were working on. You'll see that in the demo. It's really cool. And then throughout the whole process, you're governing different guardrails. You might want to have rate limits, and then like security, so you're protecting your credentials. Okay, so I just want to break that down in a little more detail. So just talking about how preparing your data, that's like cleaning your data, processing your data, indexing your data for easy access. So one thing that's really common to integrate in these systems would be a vector database, and that is used to basically store and retrieve your data, and that's helping your agent really learn from your actual enterprise context. And that's like one of the main benefits of these agents is working with your specific enterprise data instead of just being general responses like ChatGPT. And I just want to make the point that in Databricks has got all these tools that you need, like all in one single platform to be building these vector indexes, setting this stuff up, governing it effectively, organizing it all in like one central account. And you can basically get like real-time insights and seamless integration of your data into the agent's decision-making process. That's the idea. And that's why data preparation is really so important. And then when you're ready to actually build the AI agent system, the idea is you're going to have kind of like a central agent, which is at the very heart of your AI agent system. And that's the decision engine. That's what's really processing your inputs and driving the decision-making and the actions. And you want that to be based on like whatever goal it is that you're trying to accomplish. So typically that's just some kind of pre-trained LLM, and it just needs to be able to read and understand these natural language prompts. And then once you've got your central agent in place, then one thing that you can add is memory. So the agent can actually retain the context over time. That could be memory of like the conversation that you've had, like a history of chat. You can actually take that chat history and then feed it back as context for your model. And you want it to be able to recall, like if it's made a decision previously, you might want to store that and save that and then provide that as context for the future. And that's actually helping it learn from its experiences. And that makes your responses just more like relevant and personalized. And then I would say another key aspect of building the agent is like their planning ability. So just the idea that they are taking a complex task and then they're breaking it down into something that's more manageable, just like simpler steps, and then working through it in an iterative fashion. There's different techniques for that. One of them is chain of thought. So for chain of thought, basically instead of answering the query all at once, what you do is you've got the LLM, you're kind of having it articulate the reasoning process, and it's kind of like having the LLM show its own work. So it's saying why it's doing the things it's doing, saying, well, I should do this, or thinking about a different way to attack the problem. And it's going to work through the problem with intermediate reasoning steps. So that actually provides much better outcomes for like the most complex tasks where you're breaking it down. Another kind of alternative to chain of thought is hierarchical decision making. So with hierarchical decision making, that's where you actually break the problem into a hierarchy. And the idea is you've kind of got multiple levels of abstraction. So at the top level, you could have the agent kind of making more broad and strategic decisions about how to tackle the problem. And then, but it's like multi-tiered. So in lower levels, then you're making more specific tactical decisions about how to accomplish the problem. So kind of what you wind up with is a tree-like structure, and the plan gets increasingly detailed from top to bottom. So again, that kind of lets you manage the complexity of a hard problem at a really appropriate level of detail. And then another thing I just want to talk about in a little more detail is tools. So tools basically let your agent perform specific tasks. So that could be making an API call to get some relevant context from an external system. It could be executing some code, that could be a tool, or retrieving some other information like from Databricks. You've got many different data sources. And so really what a tool's job is to extend the agent's capabilities. And it lets it work autonomously. This is how you're automating a certain process or task, is by kind of modularly including these in your system so they could complete its objectives. So the kind of the analogy I like to understand this is if the agent is like the central agent is the brain of your system, then tools are kind of like your perceptual system because it's perceiving external data. And then they're kind of like your hands because it's taking action for you. And I just want to make the point that I'm going to show you guys how you can actually work with tools and integrate them into an agent in the demo. You can also kind of chain them together. So if you want to like hit an API and then perform an action with the API, you could have multiple tools that are called one after the other, and the output of one is feeding into the input of another. And the chaining is really powerful, again, with these agents. So now that we kind of covered how you'd actually build these and some different techniques you could use, I want to talk a little bit about deployment, which is where the agent takes on actual real-world tasks. And that's interacting with end users or systems or data, basically. And the thing to remember during deployment is you really want to make sure you're ensuring security and you want it to be effective at whatever goal you're actually trying to accomplish. So that would involve access controls. You'll see that Databricks has got built-in access controls with, say, Unity Catalog, for instance, which is kind of like the unified governance solution for Databricks. Then Mosaic AI has got like their gateway, model gateway, to have like all these different safeguards for your models in place. So just not anybody can access or control your model or your system, basically. And after you have deployed your agent, you still want to be evaluating these things in real time. That's to ensure you're getting the results that you want. That's high quality. So the way you're doing that is you're measuring the output quality of the agent, and you can use like certain different benchmarks to assess the agent's performance. And then that also helps you determine what are some areas that I could actually improve. So you'll see that Databricks has a way where you can fine-tune your agent. You can have custom evaluation to prevent it being too like human resource intensive. You can use LLM AI-assisted judges that are determining like whether the quality of the output is good or where are the deficiencies in the output, and it will provide a grade for the agent's different responses. And it helps you kind of trace down to what's the actual root cause of the issue you're facing if you're doing this detailed evaluation step. And then I will just say at every single stage of when you're creating, deploying AI agent systems, you need to make sure that you've got effective governance. It's totally critical for your system. You want to make sure it's covering your data, your models, and your tools. So you're going to have like access controls, cost management tools. You might want to prevent your LLM from producing certain outputs that are harmful, whether that's offensive or kind of like contrary to your company or their interests. Whatever it is, you can fine tune this stuff to make sure that the output is suitable for what you're trying to accomplish. So with Unity Catalog, you've got things like data lineage, which is essential for understanding how is your data changing over time, who's the last person that touched it, how long ago was it changed, etc. And the idea is we're managing risk, making sure that your agent is operating like it really in a transparent way, so somebody can look back and see how it arrived at the decisions and the output that it did, and be responsible essentially. And I think I mentioned this, but you have a governance tool in Databricks, which is called Mosaic AI Gateway, which we'll get a look at. And that's auditing the specific payloads for your agent. So just every single request and response is getting logged. And then you can view the details of each request response and view step-by-step how it got to the output. I'm just going to talk a little more about Unity Catalog. So this is the unified governance solution in Databricks. It covers both data and AI, which is really groundbreaking, that you can have your models, your data, your credentials, files, everything in one place, all governed in this kind of like central way. You can get very fine-grained with it, meaning that you can control like even down to specific like rows or columns of your table, who has access to what. And so it's kind of like manages all of this with different metadata that's controlling who's got access to what object. You get lineage, so that's looking and seeing how is the table or data been changed over time and who has changed it. Discovery, so just being able to have like one unified search and find like all your models, all your tables across your entire workspace is huge and essential, especially for like different teams that are collaborating, so you don't reproduce effort and have duplicate data sets everywhere. It's very easy to discover what's in your account. Monitoring is key. It's got auditing tools, and then data sharing. It makes it very easy if you've got a data set to share it very securely. So that, I would say, is whenever you're picking or looking for a platform to build an AI agent system, just keep that in mind, that Databricks kind of provides all this for you out of the box. So that makes it really effective for AI agent systems. Now, wrapping up, I just want to share some general guidelines for AI agents, and that's really going to help you maximize the potential here. First, you want to make sure that your agents are directly connected to enterprise data, because that's how they make the best context-aware decisions. Second, you really want to regularly assess your agent's performance and different evaluation methods to make sure that it's meeting your goals. And you should always use human-in-the-loop feedback to ensure not just relying on the LLM to tell you if their response is good, but actually have a human being looking at some of these responses and making sure that the output is good, essentially. And then finally, just make sure that you're governing your AI agent system, which is across data, models, and the tools that you're using for transparency and security, essentially. So that these guidelines, if you just kind of follow them, it should help you have more powerful AI agent systems. You'll be able to solve more complex challenges, and then your results are just going to be more meaningful for your organization. All right, that concludes the presentation part. Any questions on what we just covered? Yeah, go ahead, Ben.
Yeah, you stepped through the 5-step process for developing an agentic system.
Mm-hmm.
Where do you see most of the time? Like, what step consumes most of the development time?
Probably building, honestly. I mean, my job involves a lot of data preparation, and I will say like data ingestion, ensuring the quality of your data can be extremely time consuming. It's difficult. People kind of take it for granted how much work there is, how much thought there is to having your taking data and putting it into a clean, organized, tabular fashion, And especially if you're dealing with, say, like streaming data sources, or there's other complexities with the source system format, that could take a lot of time. Deployment is usually not going to be the most time. Evaluation could really take a lot of time. So yeah, I would say it probably depends, but if I had to pick one, I'd say probably building them.
Thank you.
Anybody else?
So Ryan, I'm going to throw out a different other question, because some of the examples that you were providing in the different verticals, right? I've been around long enough to know that without AI, we could automate some of those. Right? Like we could program it to do those things, right? So where is the delineation between when we are promoting the concept of AI agents to even, sort of combining multiple AI agents to do it? Is it always utilizing some sort of an LLM? Because there are other tools that could automate things and take action or reason on the context of your data, right? So how do you provide that delineation where you're like, hey, this is automation task, we can do it without AI. Here's AI where really it's important, we're building AI agents.
Yeah, so I definitely agree with you that some of the use cases I shared, there could be like a non-AI agent system solution to automating. But where AI agents are really going to shine in AI agent systems is it's bringing in the most contextual, like the latest context of what's going on in your organization, and then making a decision based on that refreshed context. So you could create like more of a dumb automation process, but it's not going to know based on the freshest version of your data. It's not going to be able to make a complex decision and do this kind of like advanced iterative reasoning process. So I agree with you. AI agent system is definitely not the answer to everything. But I will say it's up to an organization to be assessing based on the problem. Is this complex enough where using an agent, having that kind of iterative reasoning process, being able to pull in these different tools and functions to reason and then take action? Do you need that brain? Do you really need the LLM to be making complex decisions, or is it really a dumber process that would be served by a non-agent solution?
I'll ask a leading and maybe somewhat, I think I know the answer, but I'm interested in your perspective. So does using an LLM in the loop for this change the workload that you have to do setting up one of these systems and preparing of data? So maybe asked in a different way, do you have to do less work preparing the data because you're using an LLM to do some of the processing steps?
Yeah, that's a really good question. I would say probably you could get away with having more data quality issues and have the LLM kind of work around things. Kind of an example that comes to mind is like when I was talking about the RAG applications where you're taking unstructured documents, you're parsing, you're preloading it into a vector search index, and then the AI agent system is able to pull the relevant context using that index. That would potentially be a huge intensive data preparation task that has been eliminated because you're able to use a vector search index. I know that, so Databricks has got this tool called Genie, and Genie is kind of related. It's a chat where you can connect tables in Databricks to this chat room and ask questions based on that. And I find that it's kind of a matter of experimentation of like getting your data processed in kind of the right formats to get the LLM to kind of understand. So it certainly does not eliminate all data processing or data preparation needs, but you can get away with more, especially like if you're using an intelligent model. It can understand sometimes, like, I don't know, if there's typos in your, like if you're reading customer reviews, for instance, and there's typos in the reviews, like LLMs can deal with that stuff. So I think it could save you some data preparation time. That's kind of an open-ended answer, but.
And I think, right, and maybe your perspective, Ryan, and when we have semi-structured or unstructured data, it's hard to do automation on that in our world without AI,
Mhm.
right? I mean, structured data, we could do automation. Unstructured data, it becomes extremely complex, right? So AI agent potentially there, definitely a huge, boost to being able to interpret that semi-structured and unstructured data.
It's huge, yes.
About your question, definitely we had some automatic process before. However, with the agents, we can change the logic very fast. For example, instead of writing code for if else, we are defining all the logic with the words, and that's very close to our language. So developing this logic with the English words is much more faster and can be much more detailed. And these brains, which are different LLM, can work on different workflow. So in this area, agents can help a lot. Instead of developing code, definitely you were there, and there is a lot of process there. You are doing that with the boards. For example, definitely you need to make your prompt much more advanced. For example, 3,000 words, but I'm sure that's easier than coding 3,000 lines. So
No, that makes sense, right? The efficiency of changing and continuously enhancing the agents to do other things.
Yeah, I definitely agree. And you'll find that these systems can be a lot more maybe adaptable than traditional non-agent kind of automated systems.
Yeah, I have a follow-up question on that concept. So
Go ahead.
can you maybe touch on some of the model management capabilities of Mosaic, or what Databricks has to offer? Kind of relates to that last question around when you'd retrain, when you'd catch data drift, when you'd catch model drift.
Yeah, sure. So basically, Mosaic AI, it's there's a company called Mosaic ML, which was acquired by Databricks, I think last year, and they had all these different capabilities around Gen AI LLMs that are now kind of seamlessly integrated into the Databricks platform, and that's what when they refer to Mosaic AI. That's what that means, is it's this tooling that's integrated into Databricks. And then more specifically, you've got Mosaic AI Agent Framework. And by the way, I'll keep my answer kind of general because you're going to see a lot of this stuff in the demo too. But Mosaic AI Agent Framework is specifically the tools that are helping you build and evaluate agents. So in the Databricks, you've got something called the Playground, and you're able to add tools, which a tool is essentially a predefined function that can do just about anything. It can execute like SQL or Python, and you're able to put that into the Playground, and then kind of play around with chaining these agents together and having different outputs. So that's the idea behind Mosaic AI Agent Framework. It's just the tooling that helps you build, develop, evaluate these agents. And they've got like a whole separate kind of evaluation UI where you're able to view, like when you run MLflow evaluate, you're able to see based on a set of test queries, how did the agent perform for each query, and that's where the LLM as a judge comes in. The LLM can evaluate the response and tell you how reliable it was, how relevant it was. So again, I'll show you all this in the demo. And then last piece I'd say is Mosaic AI Model Gateway. So that's kind of the governance piece with the on the like Gen AI model side. So Unity Catalog is more of like governance for your Lakehouse objects, your tables, your files, etc. But the gateway is more about like rate limiting your models, making sure that your models are producing the certain output, like not producing offensive content. That's more of like I think it lets you swap out certain models without interrupting your productionalized system. So that's what's giving you all this tooling around governing and securing your Gen AI models and projects. Yeah, go ahead.
Yeah, I'm interested in hearing your experiences recently, at least with, all the advancements made with new LLMs coming out almost every week or every other week.
Mm-hmm.
All the labs and open source models, closed models. I'm wondering if recently, when a product goes, into production, have you seen that the underlying LLMs that are being used are changing as new ones are releasing? Is that a fast process? Is it slow to make sure they're, stable? Or, and to a similar extent, what do you see more closed source models, like companies using OpenAI's model serving, or like open source, given the recent advancements?
Yeah, so it's definitely both open source and closed source models are being used. If you are, I will say the models are changing quite frequently, and the model that's maybe like benching the best or the most effective in 1 week will definitely change from week to week to week. So that's why it's so kind of convenient in Databricks. It makes it very easy to swap out the model that you're using in your agent framework or agent AI agent system. And that's kind of where the Mosaic AI model gateway comes in, with allowing you to kind of like swap these out. For the evaluation piece, this is why consistent evaluation is so important, is because if you're changing the underlying model, the LLM that you're using, obviously this could vastly affect your performance, either positive or negative. And yeah, I will say like it's pretty critical to be consistently updating using kind of the latest and greatest to be getting like the most leading edge performance. But yeah, is that going to answer the question?
Yeah, I guess a follow-up to that as well. So you talk about like how it's easy to kind of swap out underlying models. Then, I mean, what I get from that is that you mentioned like the fine-tuning models with LLMs and judge techniques and human for feedback. I'm wondering, is there potential for like actually fine-tuning the weights of the model on certain tasks, or is it always just the base LLM that's kind of swappable, and there's probably a very sophisticated query framework built on top of it? I don't know if that makes sense.
Yeah, no, good question. You definitely can do more of like the fine tuning where you're adjusting the model weights. Although I will say that's just going to be a whole other ballgame. That's going to be a lot more work. So you typically want to first experiment with different off-the-shelf open source, closed source models to see if that can kind of get the outcome that you're looking for, because that's just going to save you a lot of time, resources. Obviously, like fine tuning, like adjusting model weights of an existing model is not as resource intensive as fully pre-training an LLM from scratch. But it's still going to be a lot. It's still going to be a significant cost, like GPU, power, etc. So I have not personally tried fine tuning, like adjusting the actual model weights before, but you definitely can within Databricks. Databricks had this open source LLM called, I believe, is it DBRX? And they actually used nothing but like Databricks tooling, Mosaic AI, their kind of Gen AI capabilities to completely pre-train an LLM from scratch. And it was actually really competitive with like Llama and kind of the top performing open source models, just with using all of the tools within Databricks. So that my answer is yes, you can do that. I'm not going to show that in the demo. That's going to be a little outside of the scope, but I would say try not, like, your hierarchy should be first try using like an off-the-shelf model. Then if that doesn't work, try some other strategies like tuning your prompts, prompt engineering, RAG, depending on the problem, like implementing like vector search index, and then AI agents, like adding different tools, sourcing different data. to make your answers, improving your responses before you look into actually fine tuning with the weights.
Yeah, I think there's a relatively high associated cost with fine tuning as well. So
There is, yes.
that's an additional consideration.
Cost, time, human resources, yeah, it could be more expensive, but depending on the needs of your organization, it could, be a solution to explore. It's probably not the first solution. Any other questions? All right, so I'm just going to go back. I just want to talk about the next user group meeting. I don't have the date. I don't know if the date's set, but the next user group meeting is going to be about accelerating ML workflows with Databricks. So we're going to talk about end-to-end experiment tracking, unified feature store and serving, and also proactive drift monitoring. So that's kind of the plan. Definitely follow Zorbix on LinkedIn, and we'll be posting about it. Join on the Wisconsin Databricks user group website.
That date is May 20th.
Okay, May 20th. But definitely register and come on down and join us. We'll do it virtually with the webinar again if you can't make it in person. But the purpose of my demo is I want to show you how you could actually build an AI agent system in Databricks. And we're going to be using that Mosaic AI Agent Framework, those different tools that really effectively help you set up agents. And you'll see kind of how quick it is to get started with the playground. So the goal here is to create an agent in Databricks, use it to query a chatbot in the playground. And so like I was saying before, with the Databricks AI Playground, you don't actually have to do the hard work of chaining the agents together or calling them yourself. You just type in a question. I'll show you how to create tools and then add it to this playground, and then it will know how to chain them together. You don't have to do any of that work. You just kind of get it set up for you out of the box. So first thing we're going to do is define some functions that the LLM is going to be able to execute. So those are our tools for the agent. Now these functions can be as basic or as complex as you really want. You can use either SQL or Python to define these. Okay, so hold on a sec. It's taking a long time to load. Okay, here's a really simple example of a function, and we're using SQL here. And so for my example, I want you to imagine that you're running an online clothing store, and the clothing store's website has got an interactive chatbot. And maybe you're a customer and you're asking the chatbot, you want to convert inches to centimeters for a measurement. This is kind of the most basic example, so you can see how these functions could work. If you're just using a traditional LLM that doesn't have any tools or the ability to do that calculation, you're not going to get a good result because LLMs can't do math without having some kind of external integrated tool. That's not what they're good at. So to solve the problem, what we do is we create a function, and the function does this conversion for us. So in this case, we're just kind of coding in here. You're taking the inch size, multiplying it 2.54, and then you get the result in centimeters. And what we're doing is we're running create or replace function. What this will do when you run this is register an object, the function, in Unity Catalog, which again, that's kind of like the unified governance solution on Databricks. And so when you do that, not only will you be able to use it in the playground, but you've got all the benefits of having your object discoverable, and then you get kind of like the governance, the access control. It's all built in with Unity Catalog, so that's great. So I'm just going to show you what that looks like in the catalog. Here we are in the catalog, and this is the function. That's what it looks like, and there's the definition. You can see it's just taking the inch size and multiplying. Certainly, yes.
It sort of goes back to the default. Thanks.
Okay. Yep, so that's the catalog. And then here's the function that's contained within this demo schema here. And there's the definition you could see, and then it has some things like the parameters it will take. It'll just take a single float parameter. And now that the function is created and it's registered in Unity Catalog, you'll be able to call it on demand with the AI Playground. So let's go to the playground and then test that out. Back in the playground, the first thing that you need to do is make sure that you select a model and you want it to be able to support tools. So I'm going to go to this drop down up here. And a model that supports tools, you've got MetaLlama 3.3 70B instruct. I'll use that endpoint. And you can tell that it's one that supports tools because you've got this little tools drop down here. And next, you're going to actually have to add the tools to the chat that you want to use. The more tools that you expose could affect your latency or your efficiency. So you don't want to just add too many things that you don't need. But I'll go ahead and add the schema where we have those tools stored. So that's just going to add all those tools in the schema, including the inch to centimeter conversion. So now you see that I've selected the tools that we're going to use. And now when I type in this chat, it's going to use this model, and it will be able to chain together it will figure out what's the right tool to use based on my query. So I'm going to go ahead and type in a prompt now. So I wanted to convert 45.6 centimeters to inches. And the playground is going to find what's the right function for the job, and then it's going to execute it. Then it will give you the output. It did not make up an answer. Okay, there we go. So I asked it to convert some inches, and here it's kind of output the answer. And it selected, it figured out that there's a tool that it can use to do this conversion, and it's done that, and it's given me the answer in the chat. So that is how you would use a function in the playground.
Good question.
Yes, go ahead.
Is it possible that through bad naming conventions, the LLM might miss a tool set that might be good for the job?
That's a very good question. The answer is yes. Right now, I would say it's relying on the function's name to determine what's the potential utility. Something that you can do in Databricks with Unity Catalog is this is a good practice for not just your functions, but your tables, your views. You can provide a description of what it is that your table or your function is supposed to do, what's the purpose. Each individual column in a table could even have a description. Unity Catalog will save that metadata, and then it's actually able to use it like when you're in the playground to understand what's the purpose of the function or the table that you're using, and that helps it better determine what context it should be used in. So that's a really good observation. And yeah, right now we're relying on the fact that the function has a descriptive name, but if I just named it some garbage, it would not know what to do with that, unless I gave it a description that says, this has a bad name, but you're supposed to convert inches to centimeters here.
Is there any possibility we give access to all tools and LLM choose which tool wants to use?
Yep, yeah. So that's what I've done here is you can see in the catalog, there's 7 different functions defined here, and I've given the playground access to all of them, and yet it figured out that the tool it's supposed to use is the convert inch to centimeter tool.
Okay, so all of them should be defined in one catalog, cannot be in another catalog.
No, I think you can do whatever different catalogs you want. Unity Catalog, there's only one catalog showing here. Oh no, yeah, I've got a few different catalogs here. So it can be across catalogs. It's all contained within one metastore, which is kind of the top level storage for Databricks. You'd have one metastore per account and then multiple catalogs within that. But yeah, you could have functions in all different catalogs and you could select them here. I just happened to put them all in the same schema just for the sake of the demo. Good question.
So just so I'm clear. So you had 7 different functions in one catalog.
Mhm.
And let's say you have 5 in another, you add that as part of the tool, your playground has access to all 12.
Yes,
It doesn't matter which catalog they're
correct.
in.
So now I just want to show you a more complex example of a function, and this one's going to use Python instead. So here's a function called getWeather. And the idea here is on our chatbot for our clothing store, we want to be able to take a user's latitude and their longitude and get the current weather for their location. You could imagine that their location is fed in from like an external, like a different service. And so the way that it's doing this is it's taking your coordinates and then it's feeding it to this open API, and then that will return both the temperature and also the amount of rain for those coordinates. And then if we wanted to do something more sophisticated, like for instance, provide a customer a recommendation for an outfit based on their current weather, what we could do is, I've got a second function down here. So this one's called recommend outfit description. Now this can take the temperature and the rain that you retrieved from the previous function, and it could actually recommend an outfit for you. And that could work for like a different style, depending on like what kind of, like if it's a wedding or job interview or whatever. And then based on the weather, it can give you a recommendation. And then like a basic LLM obviously wouldn't be able to answer a question like that unless you had the kind of tool to be able to feed it the relevant data, like for instance, your weather. Okay. So I just want to show you how it can answer a more complex question by chaining these together. So let me type in another question.
Can you just read the question you're typing in, Ryan? We can see it.
Yep, I'll read it.
I've got a big table in front
Okay. So the question is, what's an appropriate outfit for a job interview based on the current weather? And then I've given it my latitude and longitude. And it's going to yeah, so I'm going to try one more time, and if this doesn't work, then I'm just going to have to describe it to you. Whew, thank goodness. Okay, so I don't know what went wrong before because I didn't really change anything. But basically I'll just scroll up and just kind of show you what it's done. So I told it, please give me an appropriate outfit for a job interview based on the current weather. Then I gave it my latitude and longitude. It figured out, okay, I need to get the current weather in order to recommend the outfit. That's kind of the first step. Then it retrieves, it's using this get weather function. So it's identified, here's a tool that I can use to take a certain input and get the output that I need to get one step closer to the goal. And then this output, this is just what I got from the OpenMedio API. After that, it's going to feed that input into the second tool, which is recommend outfit description. This is that chaining of the tools together I mentioned, and the playground's just doing this for me. I didn't have to set it up or anything. And it's kind of reasoning about, okay, that's kind of a cool and dry day, but it's going to use that second tool to get a recommendation for the outfit that you could wear. And then here's kind of the whole piece together. Suitable outfit for a formal job interview, tailored blazer, a crisp white dress shirt, formal trousers, a simple tie. So these would be appropriate if there's no rain and it's maybe cooler, but you're at a job interview outside apparently. Yeah, any questions about that?
And if you would have said it's for Baywatch, it would have said swimming trunks is okay.
Yeah, presumably.
There is a question online.
Yes?
Will you be able to share the notebook link?
Yes, yeah. So the notebook that I'm using is a publicly accessible Databricks demo. I could, honestly, if you just Google it's called like LLM something.
Can you put it in a chat or something?
Yeah, I could do that. But Databricks offers these kind of tutorial things. And the great thing about this one is there's just a single line of code that you run and it does the whole installation for you. Yeah, I might as well just show you guys the demo center. So this is where I would recommend you go if you want to get more hands-on with Databricks, but you're not sure where to start. They have some awesome, like I'll just click on tutorials here. And you could see it's like different stuff by category. I don't know if I'm in the right spot. Good point. So the next thing I want to show you is traces with MLflow. So MLflow tracing is this tool that lets you debug a complex agent logic like very quickly. So you'll see in the playground, I've got this view trace button. And I actually use this by accident when I'm trying to figure out what's going wrong with the demo. But I'll click on this and you could see you're basically able to see how each tool is being called for that input and that output. So what we gave it is a question, and then what it output was a recommendation for the outfit that would be suitable. But now in the breakdown, you can see where it's calling endpoints to talk to the LLM, where it's using these different tools. Here's the get weather tool. Here's the outfit description tool. So you're able to see a breakdown of each step that the LLM engaged in to reason through the problem.
Can you see the output too at each step?
Yes. So if I click on this, then you're able to see kind of like the arguments that the tool took. So this is the weather one. It's taking the latitude and the longitude. And then you can get the output, which is here's like the temperature in Celsius and then the rainfall 0.0. So this is just what was returned by the OpenMedio API. And then for the LLM reasoning steps, you're able to see the output. You can really get a sense of like, what is it thinking? Okay, here's a tool. How can I use it to get closer to the goal? Yeah, good question. If you're using a vector database, it will show you that. If you click this little thing here, you're able to see how long each step took. So if your agent's performance, like you're having a lot of latency, this would be the first place to look to see what's taking so much time. So that's really helpful. And now I just want to talk about how you'd actually evaluate agents in Databricks. So Databricks has got these built-in evaluation tools, and that's for basically running a variety of different questions that the agent might encounter against your model. And then you can improve your agent and monitor the actual accuracy. And what Databricks can do is it will tell you, like, here's the most likely root cause of the issue if it detects something wrong for a given question. And the UI is really nice and simple to let you review what these different outputs are. And you can also compare different versions of your agents. So first I'm going to show you some code where you could use to evaluate an AI agent. Now, I don't think I'm going to be able to zoom in here, but The key here is you're calling MLflow start run to start an MLflow run. So you're able to log a variety of parameters, generate artifacts. MLflow is kind of a whole other topic I could talk about, but it's really helpful for these Gen AI use cases as well as classical ML. And then once you've started your MLflow run, then the key here is you're running mlflow.evaluate, and that is what's kicking off this agent evaluation process in Databricks. And it will take, if you've got like a list of test queries, it will take that series of queries, run it against your model, then show you the results in the UI. Now here's what it would actually look like in the experiments UI. So here's your different questions kind of on the left. It's giving it an overall score. It's evaluating on how correct was it, what's, was the context that it was given sufficient to answer the question, how grounded is it, and then how safe was the response as well. You're able to click into each of these, and you could see like how each question performed and view a trace for the question. So here's kind of what a trace looks like for a failure. And it will show you like what's the LLM is judging right now, what's like the most likely root cause. It will suggest a solution for you. And it gives you just a lot more information for each question to help you kind of tune these things and improve them. And then I just want to make a point about deployment. So once you're ready to deploy your agent to production, you can use a service called Mosaic AI Model Serving, and that's again kind of all contained within Databricks, and that will make your model available to query as a REST API endpoint. So that's it for the demo. Questions about anything I covered? Yeah, go ahead.
How is it determining whether or not there was enough context to answer the question?
That's a good question. I actually don't know the answer to that, how it decides. I know what it's kind of doing is it's like looking at this trace of each step the agent went through. And so it can tell when it's pulling data. I think it's like the LLM is judging, is this context appropriate or not based on the question, but I can't actually answer that 100%, how it's doing these kind of under the hood.
I can speculate on that. So there's a system prompt that exists in here, and the system prompt likely says, it probably gives it some instructions about, okay, take the context you have and answer the question if you feel like there's sufficient context or don't. And honestly, you probably will get different responses based on different LLMs you use, because some are better following system prompts than others. But I doubt there's anything more sophisticated than just sort of a system prompt that directs it to try to use the context.
Yeah, no, I think that is plausible.
Check out the second item there in the detailed assessments.
Mm-hmm.
It says context insufficient.
Yeah, it's giving a little explanation here. I guess in this example, it's looking at the context that was retrieved by the agent, and then it's comparing it like it's got like a document here. It's highlighting inconsistencies, I think, with like these different colors. So that's definitely something that you could look into and play with, because there's definitely a lot to this evaluation. But no, I agree with Dr. Riley. That's probably similar to what he outlined is going on under the hood. All right, if there's no more questions, I'm just going to get the link to that demo so I can share it in the webinar chat, and then I'll share it to anybody in person. If you want, just come up and talk to me, but otherwise, thank you all for coming. That concludes the presentation, so stick around and we can.